Okay guys, so we're going to have a little look at probability. So this is question 1, 2019, paper 2. And probability is, the maths in it is actually quite easy, but the wording is very difficult. So when it comes to probability, like a lot of people get confused about what is actually being asked in the question. So this one says Ben encounters 3 sets of traffic lights on his way to school. So he's gone to school, there's 3 sets of traffic lights along his way. He'll only proceed if the lights are green. The probability of each set of traffic lights being green is 1/4. Find the probability of Ben being stopped at the first set of traffic lights. Well, something that you did in first year you might not remember is that all probabilities add up to 1. So that means that there's only 2 options here. Probability of being green, you can go, red, you stop. So if the probability of being green is 1/4, well then the probability of being red must be 3/4. So 1/4 and 3/4 add up to 1, which gives us all our options. Find the probability that Ben is stopped at 2 sets of traffic lights on a particular day. Well, let's draw a section. So this is his first set of traffic lights, this is his second, and this is his third. So there are your 3 sets of traffic lights there. He could get green on the first one, but he could all get red on the second and third. So he stopped at 2 there. Or he could get red on his first one, he could go through the second one, but get red on the third. So he stopped at 2 there. Or the final option is he could get red, red, and green. So there's 3 options there, and there's a couple of different approaches to answering this question. First of all, you could add up the probability of this, this, and this. So work out 3 individual probabilities and add them together. But if you notice, they're asking for the same probability for this, this, and this. Okay, because the order doesn't matter here. So this is 2 reds and a green, 2 reds and a green, 2 reds and a green. So all we have to do is work out the probability of the first one and then times it by 3. So let's do that. So the first, the second, and the third set. And what we're going to have here is we're going to have green, red, and red. Well, probability of getting green, 1/4. Times by the probability of getting red, 3/4. Times by the probability of getting red, 3/4. Put that into your calculator and you get 9/64. So the probability of hitting 2 reds is 9 out of 64. But that's only for this individual scenario. There's 3 scenarios in general. So to figure out my probability, what I do is I times that by 3. And I get 27/64. So again, just a little bit tricky when it comes to what they're being asked, but hopefully when you see it set out like that, it won't cause too many problems. Let's have a look at part B now. So part B is a similar enough situation. It deals with different students going to school, but this time the probability is slightly different. It's 1/5 to hit a green, and there's 5 sets of traffic light. So Faye takes a different route to school. She'll only proceed if the traffic lights she encounters are green. The probability being set is 1/5. Find the probability of Faye being stopped for the first time on the 5th set of traffic lights. Well, that situation here means that for the first set, right, Faye is going to be green. She goes through that. For the second, it's going to be green. For the third, it's going to be green. For the fourth, it's going to be green. But for the 5th, it's going to be red. So she gets stopped for the first time on the 5th set. Let's fill in the probabilities for that. Probability of being green is 1/5 times by 1/5 times by 1/5 times by 1/5. But that's times by being red on the 5th set, because that's the first red one there, which is 4/5. And if you put that into your calculator, that's going to give you 4/3125. So the probability of this here being stopped for the first time in the 5th set is 4 out of 3,125 scenarios. Find the probability of Faye being stopped at least once before she approaches the 5th set of traffic lights. Okay, so that means, that's a little bit difficult. What that means is that in the first 4, so the first, second, the third, and the fourth, okay, so before the 5th, she's going to be stopped at least once. Now, you could do this in a very long way, but it will take you a long time of working out all the different situations that can happen here. So you could be stopped here, and this could be green, green, green. But you stopped here and stopped here, so you could have at least once. You could stop twice, you could stop 3 times, you could be stopped all 4 times. Writing out all those situations is unfeasible, particularly in an exam. You're inevitably going to miss some, and it's going to take you the majority probably of your 2 hours. So what we can do is we can work out the probability that it's actually green the whole way across here, that she doesn't get stopped. I know the question says that she is being stopped, but let's work out the probability that she doesn't get stopped. And that would be 1 over 5, so it's green, times by 1 over 5, which is green again, times by 1 over 5, which is green again, times by 1 over 5, which is green again. And that would give me 1 over 625. So if she went through that 625 times, she would get 4 greens. Now let's think about it. All probabilities add up to 1. So if I was to do 1 minus, and this is quite a common question, 1 over 625, right? That will give me the probability that she doesn't get 4 greens, which means she's going to be stopped at least once. So if you do 1 minus 1 over 625, you get 624 over 625. And that gives you the probability that she'll be stopped at least once. That is a very difficult one now, but it is something that comes up quite a bit.